Welcome to Your Bourse Podcast, where industry insight meets strategy for your bottom line. I'm Elina Pedersen, the co-founder and CEO of Your Bourse, the fastest trading technology in the retail FX market. Today, we have a very special podcast as we're going to dive deeper into ultra-low latency platform engineering and design. We're going to talk about how Trade Server is designed to scale performance as well as matching engine, APIs, and how all of the system works together. It's also a special podcast for me because I'm joined by Andrey Vedikhin, the founder, co-founder, real founder, I'd say, the brain behind Your Bourse, and also the chairman of our board, and also my partner in life. So welcome, Andrey.
Hi, Lina. Hi, everyone. Thank you very much for having me here.
Andrey, I know you spend hours and days and years obsessing about micros and nanos, and I hope you can share some of that knowledge with us today. But do you mind just sharing how your career started in the financial industry?
Okay, when I was a child, I never actually dreamt about financial industry. I was always interested in mathematics. And when I was maybe 8 or 9 years old, I started going to after-school classes at Kazan State University. It was all about mathematics. And my last 2 years at school, I moved from my regular school to experimental school at Kazan State University, and my teachers were professors from this university. And although I did not got a bachelor degree diploma in mathematics and physics, when we finished the school, we actually passed all the courses which usually people pass for bachelor degree in mathematics and physics. So my plan was actually to become a mathematician, a scientist, but then things changed. Soviet Union collapsed, and my parents and my relatives, my uncle, they insisted that I should forget about a mathematician's career. And I entered Kazan State University in finance, and this is how my career in financial industry started.
Okay. And once you've got the degree, which I know is a PhD degree, what did you do then?
While I was still at university, I started working for a Russian stock brokerage company. And in 1998, because there was a big financial crisis in Russia and all over the world, obviously the local stock markets were dead. And just probably 1 year before this crisis actually happened in Russia, I switched to international markets. So I started looking at FX market and exchange traded products. So I was trading by myself initially. And after that, in 1998, I proposed to my future partners in the business to set up a new brokerage, a new business, which will be providing services in FX. We started with FX, and after that, we added other products. So it was Alpari.
Okay. And obviously, Alpari has been on the market for quite a while, but you did exit Alpari in 2015
Yes, that's
after the
correct. Yeah.
S&P event. Um, and I was wondering, but what did you learn from that experience? What did you learn from owning, managing Alpari?
I learned lots of things because at university, when I was studying finance, economy, macroeconomy, I learned a lot of things, but this was only theory. So obviously, when we started with my two partners, we started this new business. I learned everything in practice, actually. But the most important thing what I learned from my Alpari days is how brokerages operate. I know their pains, I know their struggles, I know their problems they're trying to solve because I was CEO, and obviously I was overseeing all the areas of the business. But obviously, I wasn't much involved in like marketing and sales areas. I was more interested in dealing desk, technology, obviously. And yeah, I was involved on a daily basis. I had a very great team, or very good directors, very good head of dealing desk. I learned a lot from these people because they were very experienced. But yeah, as I said, the most important thing I learned from Alpari days is actually how to manage the brokerage, what are the problems brokerages have, and how to solve these problems. So I think that's the most precious experience and most relevant experience in what I'm doing right now.
So once you exited Alpari, why did you decide to convince me to start your bus instead of starting, let's say, another financial firm?
Yeah. So yeah, I kind of exited Alpari as a shareholder in 2015 after S&B event, but I stepped down from managing Alpari in 2012, I think in October 2012, and from 1998 until 2012, we as Alpari achieved a lot. We started from scratch, and in 2012, when I stepped down from management positions, we were one of the biggest retail FX and CFD brokers in the world, if we don't count Japanese brokers because they always had like crazy turnovers, etc. And I stepped down from management positions because I really wanted to do something different. And obviously, because financial industry and mathematics are the only things I know, obviously my new business should be in financial industry. But I didn't mention this, but when I was maybe 8, 9 years old, I started interested in software development. So my mom bought me first book about basic language, then about Pascal language, and she was bringing me to her scientific lab where they had used to have big computers. So I was actually writing some programs, like very simple ones, because I was a kid. So with no particular goal and purpose in mind, I was writing my first programs in Basic, in Pascal, then in Assembler, in C, C++, etc. So I was always interested in software development, in programming languages. And obviously, when I stepped down from Alpari, I decided, okay, let's do something in finance, but something software development related. And this is how Your Bourse was born. Obviously, it will take me several years, to decide what exactly I would like to do. But the choice was quite obvious, and it's coming from the childhood.
From passion for mathematics
Exactly.
and software development.
Yes.
Fantastic. Okay, so that's exactly what I want to talk to you about today, and specifically designing and building ultra low latency systems. But before we dive into that, everybody talks about low latency or ultra low latency. But what does that actually mean, and why is it important in trading system development?
Yeah, latency was always a very hot topic, and I think that we can share lots of insights today about this topic. But let's start with something else. So, first of all, sometimes people confuse latency with bandwidth. So, bandwidth or throughput, this is the number of events you can process, let's say, in 1 second. But latency means how long it takes to process one event on average, or like maximum time you need to process one event. So it is possible that you might be processing, let's say, 1 million orders per second, but every order, it will take, let's say, 1 second to be processed. Obviously, 1 million is an impressive number, but it's completely useless because 1 second per order processing, this is a terrible latency. So it's not low latency, it's not ultra latency. So that's why people need to be aware that bandwidth doesn't really matter usually, because usually in practice, nobody is having so many events, but latency is important, how quickly you process these events. And when it comes to latency, again, what is low latency? What is ultra latency? Let's try to answer this question. So, first of all, if you look at network cards, for example, if you buy very good network card, if during writing software you use some advanced techniques, I will name them. I'm not going into details, obviously. because our audience probably is not that technical. So if you use like kernel bypass, so you can squeeze latency of approximately 2 to 5 microsecond from network card. So basically,
That's the minimum you can get to on that specific network card. Okay.
yes. So if it's a good network card, if you do proper software development, like utilizing the most from what you can utilize from the kernel and network card, it's like 2 to 5, 6 microseconds.
And
And
network card, so that we're all clear, is a part of a hardware, right? It's a part of a server
yes.
that you run your software on.
Yes. So basically, if you need to send some data over the internet or cross connect, so you push this data to network card, and after that, for network card, it will take, let's say, 2 to 6 microseconds to actually send this on wire
Mhm.
on the cable. So that's why I think we can use this latency as some kind of a reference point. Because, for example, if your latency is like 20 nanoseconds and you improved it to 40 nanoseconds, that's completely waste of time, almost waste of time, because network card latency is a big number and your improvement is just a fraction of the percent. So it doesn't really matter. But obviously, if your latency is in like 100 microsecond, then obviously it's like too much. So compared to network card latency. So I think we can safely say that if your latency is in single digits of microseconds, so comparable to network card latency, I think you can claim that you are ultra low latency solution. Obviously, if it's in hundreds of nanoseconds, that's even better. But obviously, if your latency is more than 100 microseconds, then probably you can claim that you are low latency, or even you can't probably claim as being low latency. Also, what's important to say that people, when they talk about latency, they always talk about some average numbers, and average number is completely useless because what's the point if like 99% of your orders are executed quickly, but 1% of your orders is not executed quickly? And the latency is huge and unacceptable from clients and brokers' point of view. If you look at like median number, it's excellent. So you can publish it, use for marketing purposes, etc. What's very important is the maximum latency what your solution provides. So there is a type of software products which is called real-time applications. And with real-time application, the definition is quite simple. So any operation, any business logic should be completed not later than X number of microseconds, nanoseconds, or whatever. So there is a deadline. And whatever you're doing within this application, it should finish before this deadline. You miss deadline, you have a problem. Example of real-time applications, let's say self-driving car. So you will not be happy to buy a car which will be which will have like good latency for like 2 months. But after that, once it will miss the deadline, you crash, you die. So, I mean, it's not like a good product to have. So, there are some real time applications which are crucial, and missing deadline means a disaster and big consequences. In financial industry, it's almost real time. So again, it won't be disaster to miss a deadline, but it could result in financial losses. So it's not like real-time product or software per se, but again, we are very close. So basically, if you build your software and try to build a real-time application, then probably you will achieve whatever you need to achieve from latency point of view.
Is that the methodology we use at Your Bourse?
Yes, there are actually different ways how to achieve, if not real time, but at least ultra low latency things. Again, I will try to avoid any technical details, but I will have to tell a couple of phrases, unfortunately. So basically, every software developer who works in HFT industry or audio or video processing or self-driving robots, etc. So they all know the rules. The rules are very simple. So you cannot call the system calls, your like kernel calls. You cannot allocate memory, delocate memory. You cannot do locking, etc., etc. So rules are very simple. You want your software to run on multiple cores. So that's why you buy like servers with like lots of cores, like 64 cores or whatever, and you want to utilize the most of this hardware. And the problem is that you need to synchronize data which is being processed on one core. Maybe it will arrive on another core. You need to pass it to another core. You need to synchronize data. So other CPU on your server will not read the dirty data. So it should be fully synchronized. It should be correct, and it should not be like data races. So that's why if you want to utilize all CPUs, you kind of have to breach the rules. So you have to do the locking. Let's not call it locking. You need to do synchronization. And again, modern languages. Obviously, I'm a C++ guy. So in C++, in 2011, they introduced a new concept to the language, and now there are lots of available tools and methodologies how to actually do this synchronization in a very clever way. But again, it's all about design. So to follow these rules, you need to design your application correctly, because otherwise you will just keep breaching these rules, and you will never get the ultra low latency. And design of application, that's usually art, actually. So
Okay, so it's a know-how, right? How to
yes,
design a
exactly. Yeah,
certain
yes.
application, but there are rules that all developers follow, so
Yeah.
you can't allocate
But it,
memory
but
when
but
you.
it's quite impossible to follow them without good design, because technically they're impossible to follow, but with good design you can follow them.
Okay, fair enough. Um, just to just to understand it better, I guess. When we speak about trading systems, we are not only speaking about the matching engine, right? We're looking at different parts of that ecosystem. So it would be the trading platform, the matching engine. Is there anything else? And what's the whole ecosystem we need to look at?
So if, for example, we look at the typical Your client, obviously everything starts with the trading platform. But again, when we say trading platform, it's not just one component. It's not
Okay.
like a trade server. So again, usually you need to divide and conquer. You need to scale. You need to have like access servers or entry points for the clients, because if all like 150,000 clients or 200,000 clients or millions clients connect to one server, it will never be able to handle all the connections and send market data to them, etc. So obviously you have like access servers and completely different rules and requirements in terms of latency,
Hmm.
architecture, etc. applied to access servers. Then you have like your, let's say, trading server, where you keep all open positions, you recalculate P&L, margin, and all other things in real time. Then again, um, this order processing and market data generation, price stream generation usually is happening outside of trade server. Again, for the reasons of scalability, and that's a completely different business function. So you usually have either liquidity aggregator or matching engine for these purposes, and then you have, let's say, fixed API or WebSocket API connectors to different trading venues, liquidity
Hmm.
providers. How you grab this market data and push into matching engine or liquidity aggregator. You have lots of post-trade processing. You have like data warehouses. You so you do a lot in terms of post-trade processing. So it's not just like one or two components, it's basically a
Hmm.
lot of them.
So, and where does latency really matters most? Or is it for all components, or are there any specific bottlenecks? I don't know, some
Mhm.
narrow places in that ecosystem that we need to be mindful of?
I think the only place where latency, like ultra latency, is not that important is post-trade, because
Hmm.
post-trade can wait. like hundreds of microseconds, maybe even like milliseconds, but everything else is important. And also, what people don't understand, some retail brokers, they think that if the retail clients are connected via the internet with network latency of, let's say, 10 milliseconds or
Uh-huh.
100 milliseconds or 50 milliseconds, then they should not care about how fast all their components like trading platform or matching engine or liquidity
Mhm.
aggregator. But this is not precisely true, because if all the components operate at ultra low latency, that means that they have bigger capacity limit. So when something is happening on the market, we've seen last couple of weeks, you know, quite aggressive and crazy market movements. And during just normal economic data releases,
January 28th.
yeah, exactly. Yeah. So we can see lots of movements. And again, if your components operate at ultra low latency during like normal market conditions, during abnormal market conditions, they will have plenty of capacity buffer so they can handle anything. And obviously, any delays means a financial loss for the brokerage. So that's why I think only maybe post trade processing. Again, in some cases, this is also crucial, but I think in the industry we're operating in, post trade can be a little bit more latent compared to other
Okay.
components.
So so there is often confusion between fast system and fast network in a way, or ultra low latency within those components. How much latency you'd say there is in software architecture versus the physical co-location on the physical machines and the hardware?
Yeah, that's a very good question. And despite network latency being actually quite a big number compared to a good internal latency or like business logic processing latency. So let's talk about cross connects. As we already mentioned, the network card introduces several like single digits latencies if it's programmed correctly. Obviously, if you don't use advanced techniques, we are talking about probably several tenths of microseconds
So you
latency.
have to optimize the network card as well, right?
It's not optimizing, it's how you use it. So
Okay.
basically, the naive way of using a network card is actually to call functions from the kernel, from
Hmm.
operating system, from Linux, for example. And this is usually very expensive, because when you go from user mode into kernel mode, you need to do lots of things, housekeeping stuff, and it takes time. So that's why there is what's called like kernel bypass, when you basically always operate, not always, but predominantly operate in the user space. So you are not doing this like lots of
Hmm.
housekeeping
Hmm.
to switch from user space to kernel space. So, but yeah, it's like few microseconds, like single digits microseconds. Then it depends how you're connected to your, for example, liquidity providers. If it's internet, let's say if you're within London, it's like 1 millisecond or maybe slightly less, or zero point 0.8 to 1 millisecond. But again, it's not always true, because if you hosting in Equinix data centers and your liquidity provider is hosting in Equinix data center, you can get even a faster latency, because if both your liquidity provider and your hosting provider, they're using the same, like tier one internet providers, then it is possible that your traffic will never leave actually Equinix data centers, and it will be faster. So it doesn't have to go via the internet. So technically it's going via the internet, but it's within the same internet provider, so they can, route it more efficiently. But let's say you are actually not lucky and you are using different internet providers. So why the internet is usually 1 millisecond. And internet is quite good nowadays, and usually you don't have any disconnects during the week. Usually it's quite stable
If you're at
nowadays.
Equinix.
Yeah, if you're an Equinix, and yeah, again, the choice of data center is important, and it's all about how good is the infrastructure actually at the data center. And Equinix is the best choice for these purposes, because they know what they're doing. So Internet is 1 millisecond. If it comes to cross connect, so we are talking about probably tens of microseconds to maybe 100, 150 microsecond usually. So, and the question is, do you need to try your best to improve your internal latency, like to make it not like 10 microseconds, but 2 microseconds if
Internal,
you
you
have,
mean software
yes,
architecture?
software architecture,
Mm-hmm.
yes. So let's say matching engine. So
Mm-hmm.
your matching engine latency when the order comes into matching engine and when the result leaves the matching engine, like order execution, or
And in our case, that is
we are talking about 2 microseconds approximately. But again, now we have some prototypes which can reduce this even to hundreds of nanoseconds. But again, we'll probably talk a little bit later
Mhm.
about these measurements of
Mhm.
latency, because this number usually can mean a lot or nothing. But we will talk about this a little bit
Okay.
later. Yeah. So again, when you see this network latency of, let's say, 100 microseconds over the cross connect or 1 millisecond over the internet, you might ask yourself a question: why do I need like 10 microsecond, 2 microsecond latency, etc.? So, because the network latency is big, but as I already mentioned, the lower latency means the higher capacity. During abnormal markets, you can handle a lot, and you will be able to actually, and also the ultra
If
low
you have this ultra
yes,
low
yes,
latency, so
yes,
it's not about
exactly.
how quickly everything happens, it's more about the
Yes,
throughput of the total
yes.
system.
And also, if your system is written with ultra low latency things in mind, that means that your maximum latency probably will be within very, very good numbers. Yeah. So that means that when the markets like falling, or like something is happening on the markets, you will be still able to process everything very quick, very quick.
What do you consider to be a good number?
For maximum latency or average latency?
Maximum.
Maximum latency, I would say around 50 microseconds maximum latency is a good number.
Mhm.
And for ultra low latency, I would say below 1 microsecond is an extremely good number.
Okay. And I'm just interested, who does this like who can most benefit from it? Like, does it really matter to a retail trader? Or are we talking about HFTs that get their edge in trading from benefiting from that data, like ultra low latency data? Who is this important to and why?
Mhm. So it depends whom we are talking about. So obviously, when it comes to HFTs, this is what they do. They need to be fast. They need to win. They need to be faster than other market participants. If they're not fast enough, they start losing money. So for HFTs, obviously, that's it's like real time applications. So they miss the deadline, and there is a financial loss. Again, they have risk management strategies to limit this one missing deadline in terms of financial loss numbers. But again, this is their like bread and butter. So this is how they operate. When it comes to, for example, retail clients, again, um, from retail client point of view, this latency only affects them when there is a very big market movement, and if the broker is stuck, if their internal systems are stuck because they just can't handle so many like price updates, orders per second, etc., etc., and latency spikes to unreasonable numbers. So obviously this affects them. But if broker operates like perfectly and can handle within like reasonable limits all their orders, so they obviously don't care whether it's like 2 microsecond or 5 microseconds. So they don't care because the network latency kills this like small number. So it's just too big comparable to internal latency. When it comes to broker, I think although even if it's a retail broker and serves only retail clients, doesn't have HFTs or similar financial institutions as their clients, it is still important to have this low latency just to be prepared to crazy market movements. just to be able to handle lots of lot without any delays. Because again, delays can cause financial loss.
So, do I understand correctly that reducing the latency variance, which is also called jitter often, is more important than actually lowering the average?
Yes, that's an excellent question, because if you, as I said, if you lower the leverage from like 20 microseconds to 2 microseconds, probably there will be not a lot of like net benefit of it. But if you reduce your maximum latency, so this is where you will get or jitter, reduced jitter. So this is where you will get the most of the benefits. So that's why, as I already mentioned at the beginning of our conversation, the real-time systems, there is a hard deadline of the maximum latency. So that's why, for example, one of the things what we measure a lot at Your Bourse is actually maximum latency number. And we try to reduce the maximum latency number, because the average is very easy to
Mhm.
reduce, but the maximum, it needs extra techniques, extra, knowledge, experience. It's hard. It's hard.
Okay. So, now that we've unraveled the latency subject, I was wondering if you can talk a little bit about those components that you've described before. And if we start, perhaps it's wise to start with our flagship component that was the first one to hit the market, and that's the matching engine. So, on a high level, what does the matching engine do in its nanoseconds?
Okay. So I will talk about our margin engine, like architecture, and
Matching engine, yeah.
sorry, matching, not margin, matching engine architecture and functionality. So all the quotes which are coming from liquidity providers and trading venues, we convert into limit orders. And within our matching engine, we have a central order book. And obviously, because our clients, they require different execution rules, execution profiles, markup profiles, etc. So this central order book we split into what we call virtual liquidity pools. So obviously, from broker point of view, it's just liquidity pool, but from our point of view, it's one central order book, and we have these virtual liquidity pools with very low overhead to maintain them. And our matching engine, actually, based on the configuration it has, it applies different like order routing rules, it applies different markup profiles, different matching profiles, who can match with whom, liquidity depletion, you know, customizable volume bands, and like probably like hundreds of different business logic parameters and functionalities. So matching engine is quite heavy in terms of the business logic, and all this business logic is applied in real time. And this is what we have to achieve within like hundreds of nanoseconds or single digits
Okay, so
microseconds. Yeah.
those individual events, they are sub micros, and the whole cycle, so to say, you said it's
Yeah, 2 microseconds. But
micros.
what we measure the full cycle. We call it full
Okay.
cycle. So basically, once we have got the package on network card representing a new order, for example, and until we completely finish its processing. So this is what we consider. And as I said, we don't distinguish like market data much, because all these quotes from liquidity providers we just convert into limit orders. So from our point of view, it's always about one order processing. So it results into market data and is sent to market data subscribers, obviously, but it's like the full cycle we measure.
So, what determines how much a matching engine can actually handle?
Architecture. Yeah, because as I said, rules for programmers, for software developers are simple. Don't do this, don't do this, don't do anything. And obviously, in real life, you have to synchronize when you pass data from one CPU, which is handling like networking thing, to the CPU where the thread is running, handling the business logic, etc. You need to divide and conquer. You need to parallelize your executions, etc. So it's all about architecture. So how you can achieve impossible? So you are prohibited to do things, you have to do them, but in a clever way. So, and this is usually know-how.
Okay, so how important are the data structures for the order book, and why isn't it just like a database entry kind of problem?
Yeah, first of all, when it comes to databases, you can't use databases when it comes to ultra low latency because databases are very slow. You can use them for post processing. So after the trade already happened, all execution reports are sent, processed, etc. You can start saving the data post factum, post trade into like databases for easier, like reporting purposes, etc. But again, you can't hold your data, real-time data in databases. So databases is a big no. It's even worse than saving things on the disk or sending via the network, which is also a big no in ultra low latency processing, and it's handled differently. So why the data structures are important? Because when it comes to central order book, it is possible that in this central order book, it might be like 1 million bands or like price layers or like orders in the central order book. And obviously, you need to do lots of operations on this data, on this central order book. You need to find an order, you need to insert the order, you need to delete an order, you need to find and amend the order, the quantity, the price, or whatever. You need to do the matching, etc. I think we counted, was it like 14 or 15 operations we need to do on the central order book? And the problem is that all these operations should be very fast. So again, in software development, we use the measurement, which is called big O. This is the algorithm complexity.
Hmm.
So O1 means that everything can be done in one action. So basically, you know where to take the data, and it takes only like one action. There is on another side, and there is like logarithmic, for example, complexity. When if you have like 1 million orders, you can, and 1 million, this is approximately a 2 in power of 20. That means that you can do your operation in 20 steps. 20 steps is okay. And also the worst case when you need, let's say you need to find particular order among 1 million orders. Obviously, if you go through all 1 million orders to find it, so on average, your like number of steps you need to achieve is half of million, because usually on average you will find by doing this many iterations. And obviously, the more things you do, the more time you need to spend doing things, and the latency rises. So that's why it's very important to design such data structure that every of these 14 or 15 operations can be done in with O1 complexity. So in one step, in the worst case, logarithmic complexity, let's say 1 million orders, and you just need to do 20 steps. But again, hot path, the most intense path, should be O1 complexity. So that's why to design this data structure is again art and a little bit science.
Okay. So, what can cause a latency spike within the matching engine or within the system?
Okay, it's a very good question because it doesn't matter how well you design things and how fast is your matching engine or any other application. It is still possible that this application will at some point will not be able to cope with the load, etc. And sometimes it's completely outside of this application's control. So basically, when you create a low latency application, it doesn't mean that the whole application is low latency, because it's not possible. Because usually the application needs to speak to other servers via the network or save some data, for example, to the disk. And disk operations, network operations are quite slow operations. And usually, when you design this application, what you do, you actually pass this slow work to another threads, and they do them like not in background mode, but these threads are no low latency. So basically, all the matching in the matching engine is happening in the ultra low latency manner, etc. But when, for example, execution report is ready, usually what you do, you put this into log-free queue. So again, you can't lock things, but you need to synchronize things between the threads. So you put into log free queue, and after that, some other thread will pick it up from there and send it by via the internet, for example, or save it to the disk, etc. And to put this execution report or any piece of data into log-free queue usually is quick, and that's why you can still be ultra low latency in the hot path, in the business logic threads, which needs to be very fast. But again, and usually you make these queues big enough not to be full at any time. But again, sometimes crazy things can happen on the market that these queues are full, and obviously the ultra low latency thread needs to wait until this queue is emptied by another thread. But also sometimes it can happen even outside of application control. If, for example, let's say network is slow for whatever reason, or the other component on another side cannot handle fast enough, etc. Or, for example, some other application writing on the disk and completely kills disk performance. And although your application is fast, but it's not the only application on the server. So you have, I don't know, like data warehouse doing some writes to the disk, and because it's like crazy movements, lots of writes are happening, lots of disk activity. So it is possible that these factors outside of matching engine control, for example, or any other component control, can affect performance of network or disk or whatever, and you can hit the limit. And but yeah, it is possible, but
And that causes a latency
yes,
spike
this
then.
can cause a latency spike even in a well-designed system
Okay, so
and
I mean, you
well-written.
can be driving a supercar, but once you hit the
A truck,
serious
yeah.
stretch of M25,
Yeah,
you're
yeah, yeah, exactly, yeah.
you're in a
Exactly.
traffic jam and you're
Exactly, yeah.
waiting for it to. Okay, how do different order types or execution rules affect the performance of a trade execution system?
I think in our case, for example, order types, it doesn't matter which order types, they do not affect
Hmm.
performance. They treat it like equally, kind of. Obviously, if there is like an expiration on order, we just register it somewhere and we are getting notified when the order is expired, but this is so negligible. So technically speaking, it doesn't matter what order types we process. Execution, again, profiles, execution, business logic, etc., can affect a little bit, not a lot, because usually we try to use O1 complexity, again, one action to do anything. So that's why they all also quite negligibly affect the performance. So that's why I would say it doesn't really matter for us. Yeah.
Okay, fine. So now that we've spoken about the trade execution within the matching engine and the trade engine, I would like to talk a little bit about the trade server, which is our new
Mhm.
product. And I think that a lot of people would confuse the trade execution system with the trade server itself. And a lot of people believe that the trade execution system is the most latency critical component. But in fact, the trade platform also affects the performance of the whole setup. So, how does it affect the performance? And what should be optimized as a first instance? Is it the trade execution platform or is it the trade platform?
Yeah, as already mentioned, that all the components except probably post-trade components are very important, because if your trading platform is not fast enough, then obviously your clients will see delayed pricing. Again, This probably won't affect the execution, but again, this will affect the like user experience when, for example, they see that the price updates are not frequent enough because the trading platform just can't cope with so many online connections, so many price updates, and obviously for retail market data, usually throttling is in place. When it comes to institutional clients, obviously no throttling, and they need to see all the price updates. And again, if your system trading platform is not capable enough, and why I'm saying about market data, because market data usually that's the most of events, because you can get like tens of thousands tick updates per second. And in terms of when it comes to trading, usually it's, I don't know, like 1,000 trades per second, 2,000 trades per second. So it's probably like 1% of lot compared to the market data. So that's why to efficiently distribute market data to online connections is extremely important. Luckily, it's not the hard task to do because you can easily scale it. So usually all these trading platforms, they have what is called like access servers or entry points for the clients, and they actually you can install as many entry points or access servers as you want. The more online connections you have, so easy to scale. So, but again, still you need to be quick and efficient. But the most challenging part in the trading platform is actually the trading logic, because usually clients they have open positions, you have lots of ticks coming in, you need to recalculate P&L, margin requirements, you need to execute margin calls, stop outs in real time, because if you miss again, if you are late, then again, this could result in financial loss when position is not liquidated fast enough. So, and this is like lots of calculations and lots of ticks. If you do calculations on every tick again, this is just lots of calculations. Let's say you have 100,000 open positions. Let's say in 1 second you've got, let's say 10,000 ticks only 10,000 ticks. Technically speaking, 10,000 multiplied by 100 million, sorry, 100,000 open positions, it's like 1 billion, if I'm correct. 1 billion calculations you need to do. So, and that's a lot. So, and that's big
And
complexity.
how quickly do you need to do it?
Again, it depends. So, technically speaking, you need to do it on one tick,
On each tick?
on each tick, yeah. But again, in our case, we introduce some heuristics. So I will give you a very naive example, but you will understand what I'm talking about. Let's say there is a client with like $1 million as a deposit, as a equity on the account, and this client has a micro lot euro dollar position. So obviously for this client, you don't have to calculate this on every tick, because like for stop out purposes and margin call purposes, because it's just not possible, for this client to reach it. So obviously for such clients, you can calculate it not on every tick. So you can skip some of the ticks for such clients if you are busy. Obviously, if you are not busy, you still recalculate it on every tick, but you can introduce this like heuristics, how to optimize a little bit your calculations and skip ones which are not affecting the brokerage operation, the risk management.
Is that more of a business decision than, let's say, architectural decision, or is it
Business decision is very simple. So if you ask dealing desk, they will say you need to calculate on every tick.
okay?
But again, and this is what you try to do, but again, if you are not capable, for example, if like the market is just dropping like minus 20% in crypto, and all these positions needs to be liquidated as soon as possible, obviously you it's like in life, you focus on important things,
Okay.
and after that you deal with the rest. But also, what's also challenging in this trade server, usually there is lots of market data coming in, and usually market data is processed by like some threads, some thread pool on some CPUs, and there is like trading data. All these recalculations are being processed by a completely different like module, let's say, on different threads. And again, one of the most difficult questions is how you can recalculate your P&L and margin without being without blocking the market data coming in. Because the naive approach is we've got the tick, we put the lock, we lock everything until we process this tick, we go through all the positions, all the orders, working orders, pending orders, and we see if this pending order needs to be triggered, executed. We recalculate all P&L, all margin requirements, equity balances, margin levels, etc., etc. After that, we unlock and say, okay, now you can proceed with the next tick. And this is a disaster. So this is how it should not be working. And again, in our case, in our Your Bourse trade server, we managed to make sure that these are completely independent modules, and market data is not dependent on these margin calculations, P&L calculations. It's not being blocked by this part of business logic. And obviously, when we do these recalculations, we still get the latest ticks. And again, this is a little bit know-how, and this is how we solve these problems. And this also contributes a lot to performance.
Oh, okay. Well, I mean, obviously, I guess that's how
I,
you manage to do everything without slowing things down. And as I understand, this is before we even reach the matching engine,
oh,
right?
yes, yes, yes. And yeah, as I said, every component, maybe except post-trade processing, is very important to be low latency because yeah, everything works when the markets are normal, and things can break when the markets become abnormal. So you need to have lots of capacity.
So, what do you think are the biggest mistakes that technology vendors make when they design their systems, from your experience?
Yeah, again, it depends which component we are talking about. For trading platform, I think one thing I mentioned already is market data incoming market data being blocked by all this like P&L and margin
Hmm.
calculations. So this definitely this problem needs to be resolved, because otherwise, if market data is blocked, lots of latency issues will arise. When it comes to, for example, clients connecting, like lots of online connections, again, this is quite simple. So it's not like the biggest technological challenge, because this is where you can divide and conquer. You can just deploy lots of access servers. But again, as an architecture, you need to have this kind of big picture architecture where you have like main trade server and access servers, etc. Obviously, quite challenging is real-time replication of data. I mean, challenging from a software development point of view, and challenging and interesting when you need to replicate your data on the main server in real time to your backup servers. So if things go wrong with hardware or some other things, you can always have real-time backup on another machine where you can start a new server actually and continue your operations without interruptions. And again, with matching engine itself, yeah, challenges like everywhere. And the most important, probably the central book structure, data structure. So, but like challenges everywhere. So
That's
it's
that's
interesting and hard and interesting. Yeah.
okay. So looking back into the hardware side of things or infrastructure side of things, right? As I understand, with the software architecture, you can potentially shave a couple of dozen of microseconds, as you said, like we can shave 50 microseconds here and there. But with just cross connecting or co locating, you can actually shave that 1 millisecond, right? That is internet. How relevant is it actually for brokers?
As I already said, that your internal latency, why it does matter, to be able to handle extreme market conditions. If you are serving only retail clients, the network latency is not that important, because your end clients already have a network latency of at least several milliseconds, but usually even like 10 or 20 or 30 milliseconds, because they are connected probably from their homes, offices, etc. So that's why, but for brokers to be able to handle all this order flow and market data during extreme market conditions, it's very important to have very low latency,
And
internal
and
latency.
what
Yeah.
about having the infrastructure spread across different vendors? So obviously you have liquidity providers, they use specific systems to connect into your matching engine through
Mhm.
fixed API, for example. Then you have various trade platforms, I don't know, front ends to the trade server connected there. Like how reliable it is to spread it across different vendors.
It depends. If these vendors they have very good low latency product, then we do not care about internal latency. When it comes to network latency, again, it depends on your business setup. Let's say, for example, there is nothing wrong to host in like Google Cloud or Amazon. But again, if your liquidity providers are in Equinix data center, so obviously via the internet, it will be a latency of 1 millisecond. But if you order a cross connect from, let's say, Amazon or Google Cloud to Equinix, I don't know the number for Amazon, but for example, for Google Cloud, your network latency will still be zero point 0.7. It is probably will be more reliable, but again, as I mentioned before, internet nowadays is quite reliable. So lots of our clients are not using cross connects. They're connected via the internet to their liquidity
It's their
providers.
choice,
It's
right?
their choice, yeah. So again, they need cross connects. We can provide them with cross connects. And even if they don't order cross connects, but if they're connected to liquidity providers using our hubs, obviously it's not leaving our infrastructure, so it's still kind of going via the local network via like cross connect, although technically speaking from legal point of view it's a connection via the internet. So ag- uh, I forgot what I was talking about. Yeah. So yeah, what I'm saying, it depends on your business model. So if network latency of let's say 1 millisecond is good enough, because you're serving only retail clients who are not cross-connected to your systems, then you just need to make sure that your vendors can handle this amount of market data, orders during extreme market conditions, etc., and everything just works fine without any delays. But again, if your clients are HFTs, then probably even like cross connects might not be enough. You should be talking about
I
like
don't think we'll be
collocations.
speaking about real HFTs here,
Yes, yes,
that
agree,
try to look at
agree.
receiving data
Yeah, that's
before
not
to
a
get
pro.
an edge.
Yeah, yeah, that's not the industry we are operating at the moment. Yeah.
That's a very important subject, really, when you say, when you look at these vendors, you need to understand what's their latency and how it all works together. But, our industry is full of ultra low latency claims where I don't think some vendors even understand what ultra low latency means or understand the difference between nanoseconds, microseconds, milliseconds, and seconds sometimes. Is there a way for the potential broker client to verify those claims? Is there anything they can do to actually be able to navigate it?
Yeah. So first of all, because our industry, let's say technology providers in this area, we are not regulated, so there are no specific rules we need to follow when we are making these claims. And actually, the numbers you can see in like marketing brochures or salespeople talking. So quite often these numbers coming. So first of all, they might be not true at all. So they can be just made up numbers. But even if they are not made up, sometimes these numbers are coming from stress testing in a very ideal environment. So when you have, I don't know, like 100 symbols only, when you don't have lots of like business logic parameters enabled, when it's like a very powerful server which is more powerful than whatever used in production. When it's only your testing application is running on this server, because usually in production you have, I don't know, like 10 or 20 or other like components running on the same machine, and obviously it's a completely different picture from like latency and stress testing point of view. Again, these ideal results, and again, this is probably when orders or some like market data events are being sent like in a specific manner, because the real life is quite different. So first of all, when you run your components in production, so as I said, most likely it's not the only application on the server. Usually you have multiple components running on the same server. They all compete for the same CPUs. They all compete for the same cache, network card, etc., etc., etc. So they create contention. And if in ideal testing you can achieve, let's say, 2 microseconds, then on production machine probably it will be like 10 or 12 microseconds, just because it's not the only application running. Plus also the live like market patterns in terms of market data completely different. So everything could be in like everything is normal, and after that suddenly you've got like, I don't know, like 1 million price updates like across 100,000 symbols like in one go. When you stress test, usually you introduce some what's called like wait strategies or like back off strategies, etc. So if you cannot push, you just like wait one CPU cycle or whatever. So again, the real markets, they are not going to wait. They just like, it's like avalanche. So it's just goes into the system. You need to handle it. Lots of contention. So, and the real production data latencies could be completely different from what you can achieve in stress testing in ideal environments. So, because we are not regulated, again, what you hear from salespeople, what you see in the marketing brochures, again, you don't know whether it's like made up numbers, whether it's numbers from your like ideal stress testing environment, or whether it's like a production data. So, obviously, we as UBurse, we monitor latency for our clients in production, and for us, it's the most accurate data, because different clients, they have different setups, different business tools and parameters they use. And yeah, we monitor this in real time, and we can see, so we know what's our like real production latency
And
is.
that's what we publish usually, right?
Yes, that's what we publish. Oh, I hope I'm not part of this publishing process, but I hope, yeah, that
Well, you're the one providing, your team is the
yes,
one
yes,
providing
yes,
the
yes, yes.
information.
Whatever, yeah, we provide, that's based on production data, not like ideal testing, because in ideal testing we can achieve like 200 nanoseconds or 300 nanoseconds, but in production, obviously, it's an unachievable number for the reasons I already explained. But also, what's important, as I said, lots of these numbers are provided in percentiles, like 99% of time we have this latency, 99.9% of time we have this latency. Again, I'm not sure whether we publish or not, but
The
for us,
percentiles.
yeah.
No, we
No,
don't,
okay,
because you
okay.
said we can't.
Okay, that's fine. But what we look as developers, when we look at production data, we look also at maximum latency. And all our development efforts are actually focused on reducing this maximum latency to become as real-time system as possible, based on the definition I provided. When missing a hard deadline is bad, very bad. So that's what we are focusing. And usually, like maximum latency is never published by anyone, because, yeah, sometimes it's very hard, or not sometimes, always it's very hard to achieve a good number in this area.
So, if you're a broker and you're sourcing a vendor, what would be your question to the, I don't know, CTO, whoever, the technology vendor? What would you ask for?
That's a very hard question.
What kind of data should you be asking for?
Yeah,
Performance data.
yeah, I think it's definitely should not be sales pitch and marketing data. I think if you can somehow get the production data from this vendor. Again, I'm not sure whether it's like technically possible or not, but if you somehow see the production data in real production setups, the latency data, the bandwidth, everything, then probably it will make you more comfortable whether to choose this vendor or not.
So latency distribution, the maximum latency, right? So throughput under load, I assume,
Yes,
some
yes.
sort of
But as I already mentioned, throughput under load is probably not the best number because usually everybody has a very good throughput. But again, latency is more important. As I already mentioned at the beginning of our conversation, that it doesn't matter that you can process 1 million orders per second if you are processing each order 1 second. So if the latency for each order is 1 second, so it's just totally unacceptable. So that's why throughput very easy to achieve. Latency is probably what you need to focus on. Yeah.
Okay. Last question. No, not the last question, but one of the last technical ones. I'm just wondering, so how, with all of this, with everything you've described, and for example, when you were talking about the trade server, right, and how you shouldn't be locking the system for certain calls, I know that this is quite, well, it's not innovative now, but it used to be an innovation. And that's the reason why some older platforms, for example, do it,
Mhm.
because it was just not available to them when they coded the system, right? So
Mhm.
technology constantly develops. So how can you balance this innovation with the stability of the product?
Lots of people think that, for example, C++ language is dying, but it's not. Maybe it was dying until 2011, but in 2011, I can see there are lots of innovations happening every 3 years to C++ language. And for example, the memory model was introduced in C++ 11 in 2011 year. And this memory model introduced some features of the language which make it possible not to use logs, but again, to use log-free mechanisms or even better wait-free mechanisms without actually taking log when you can synchronize data between different CPUs and threads. And after that, every new standard, which is happening every 3 years, introduced more and more features. So that's why if your code is quite old, it is possible, unless you rewrote these parts of the code, that it's not using the full potential of the language, as well as it's not probably using the full potential of hardware, because yeah, lots of things changed in C++ language, so it's not dying at all. So it's rapidly progressing. New things are being introduced every 3 years. So that's why we, for example, we always update compilers, we always introduce new features released in the new standards in our code, because this make it faster, safer, and easy actually to write.
So innovation is stability, or is it vice versa? So innovation actually, does it improve stability or does it reduce stability of the system?
Yes, innovation is good. And for example, when it comes to C++, all the innovations we see recently during last 10 years and especially last coming years, and the new standard will be published actually this year, 2026. And we see that they're trying to make code or coding in C++ safer. So to make sure that it's much more harder to make a mistake and introduce like a vulnerability or a bug, etc. So I'm not going to go into these technical features, but whatever features they are planning to release this year, new features, this will make coding and applications safer, faster, obviously, and it will be faster to create applications as well.
So why, I mean, keep coming back to C++, but how important is actually the choice in the programming language for designing a system?
Obviously, I'm a little bit biased to C++ for obvious reasons because I'm a C++ person. Although, as I mentioned, I started with like basic Pascal, but it was like 40 years ago or more even. But now I'm in C++. And I believe that C++ gives you lots of control over the very low detail, kind of low level things. And that's why whatever you create, obviously, if you're experienced, whatever you create is fast and quick. And also, the recent additions to C++ made it to do this coding quite quickly because previously, let's say 20 years ago, you needed to do lots of housekeeping. So you achieve a very good result, but you need to do lots of coding, lots of boilerplate code, etc. So with all these like recent features C++ introduced, obviously the coding is not like similar, but very similar to like C Sharp or Java. So lots of things are already handled by the language standard, but you still get the full control over the low level, which makes your code faster.
When you say low level, you mean hardware, right?
Like memory locations, it's not hardware, but sometimes hardware again, because you can write synced instructions, to utilize the full power of like modern processors, etc. So we write like branchless code, for example, to reduce work on branch predicts of modern processors. We create like cache-friendly code again, and other things we use. Again, in languages like Java and C Sharp, you can potentially go down to this low level. Sometimes it's not possible. There are things which are not possible. There are things which are possible. But when you do this, it's like you're coding in C++. But
So what's the
again,
point?
what's the point? But you still have, yeah, so you just need to do too much efforts to achieve. You will not be able to achieve the same results, but you can get as close as possible. But this is like so much work. So what's the point to use like Java or C Sharp if you don't get the performance, but it will be very hard work actually to achieve it, to be as close. There are some other languages like Rust, etc., so which are kind of in between, etc. But I think C++ with recent additions, it's a safe language. It's language where you can do software development very quickly, and obviously it's the fastest.
Okay, fine. Last question then. If you could give one advice to the audience, to the brokers, to the broker clients, what would it be?
I think that brokers, they need to understand a very important thing. So lots of brokers, they start thinking about creating their own like bridge, for example, or like trading platform. And I think this is a mistake. And I'm talking from probably Alparis experience because we had a very big team of C++ developers. We had a very big budget actually to create our own what we call the ECN, a matching engine, and other components. So it's very expensive, and it is possible that you will be successful. You will create a great product, etc., etc. But again, the problem is that this product probably will still be missing lots of features because it's a completely different business. Software development is a completely different business. You do not write like operating systems, you just use the existing ones. So I think that the brokers, they need to focus on what they do best. They need to attract clients, they need to serve clients, and they need to leave creating this like applications, matching engines, trading platforms to specialized vendors, because this is the business for the vendors. They know how to do it. They know how to do it efficiently. They have lots of feedback from different clients. They have lots of features which can improve your profitability 10 times, 20 times, etc. If you are a broker and you want to create your own product, you might be successful, but most likely it will not be as feature rich as if you use like a specialized vendor. And also, it is definitely you will be spending maybe 10 or 20 times more money to develop this product, plus additional headaches. So I think brokers need to focus on what they need to do in terms of their business model, attract new clients and process this order flow, like set up business rules, risk management profiles, models, etc., by using third-party vendors. I think that's my
If you could
advice.
so how do you get a competitive edge using third-party vendors?
Oh, that's a very good question. Yeah, I think what brokers needs to focus on is their own front end, and the reason being is, first of all, this front end make them different. So people will see some uniqueness in their front end. In this front end, they will be able actually to introduce some features which are not available among competitor front ends. But also with this front end, because we are living in 2026, and that's a completely different time compared to like 10 years ago, etc. With this front end, they can do onboarding, they can do any communication with the client. Nowadays, to open account for young people, for example, for young generation of traders, it's just easier to download like an application, for example, from App Store, and after that start trading like on demo account, and after that you start communicating through your front end, through your application to these demo accounts, trying to convert them into live accounts, to deposit money, etc. So your own front end is a very great marketing tool, and this is the new way actually of signing accounts and getting new business.
But it doesn't necessarily require you to understand the complexity of all the margin calculation
Oh yes, yes,
validations and
yes, yes. To create front end is, I can't say it's an easy task. To create a basic front end, it's an easy task. Obviously, if you want to do something very unique, obviously you need to be creative. But again, from software development complexity to create a front end, as long as all the heavy lifting is done by the trading server backend, is quite simple. There are lots of frameworks, lots of people who can do it. The budget will be reasonable.
it's
So
all about understanding the customer and the
yeah,
customer journey
yeah.
when you
For
do it.
example, yeah, at your Bourse trade server, so we do all this heavy lifting in our backend. We provide very good APIs, which will allow your front end, for example, to do anything, whatever you want. We pre-calculate things, so it's quite easy.
Okay, fantastic. I think that's been very insightful. Thank you very much for coming here finally. Only took 2 years to convince you.
Thank you. Thank you very much, yeah, for having me today. Thank you. Bye bye.
Bye bye. like, subscribe, comment. I don't know what else my marketing would like me to say. But yeah, stay tuned for the next podcast.
See you next year.